In today's lesson, we are going to be applying the knowledge that we learned in last class about SOHCAHTOA and solving right triangles to word problems. So one of the main goals today when you go through is learning how to take the word problems, read them, and set up a picture that goes with them. And then once you have the picture, it's the same kind of solving that we learned in the previous lesson. So some of these problems are going to contain a couple of important phrases. And so we're going to look at these two phrases and talk about what they mean to us. So angle of elevation is one phrase that you're going to hear in a lot of your word problems. And so the definition of angle of elevation is an angle that rises from a horizontal base. Now the important things here are that you have to have a horizontal base and you have to rise from that base. So in picture form, this is what it would look like. Horizontal means this direction. So there's your horizontal base. And then from this line, I am going to rise up. So an angle of elevation is an angle that goes up this direction from a horizontal base. Angle of depression. This is an angle that falls from a horizontal base. So again, you need your horizontal, but the difference is it goes downward. So your angle ends up there. Again, we go down from a horizontal base. And so if you notice, they look similar, but one is going downward and one is going upward. This is going to be important when you are dealing with your word problems and making sure that you're drawing your triangles correctly. So let's take a look at our step-by-step instructions. First, draw a picture that represents your problem. This requires you to read the word problem, sometimes read it more than once. Draw trees, draw people, draw the ground, draw buildings, draw whatever it is that they're talking about. Once you have a thorough picture, then you're going to label, of course, your angle with theta. We've seen him before. And you label your sides with O, A, and H. Then, of course, choose the appropriate part of SOHCAHTOA. Set up your equation, like we did in the last class. Solve for the missing piece of the equation, like we did last time. And most importantly on these, because these are real-life problems, you must remember labels on your answers. Things like feet, inches, degrees, miles, whatever the word problem is talking about. So that being said, let's take a look at our first example. An airplane flying at 20,000 feet is headed toward an airport. The airport's landing system sends radar signals from the runway to the airplane at a 5-degree angle of elevation. How many feet measured along the ground is the airplane from the runway? So let's look at some of the things we're talking about. You have an airplane that's flying at 20,000 feet. Okay, when they talk about an airplane flying, they're talking about how high off the ground the airplane is. And it's headed toward an airport. Well, the airport we naturally know is on the ground. And so we're going to be drawing a ground here momentarily. Let's see, it says radar signals from the runway to the airplane are at a 5-degree angle of elevation. And then the X part of it is the most important part. How many feet measured along the ground is the airplane from the runway? So here's some things that we need. We obviously need an airplane in the air. We need the ground. And we need an airport that contains a runway. So the ground naturally is down here. The airport obviously has a building. It's got runways. We're going to call this the airport. Your plane is not directly above the airport. When planes come in, they're coming in diagonally. So you have an airplane somewhere over here. Don't make fun of my drawings. So you got this airplane that's flying in the air and heading eventually towards the airport. So let's talk about what else we know. We know this airplane is 2,000 feet above the ground. So if I draw a line straight down from the airplane to form a nice right angle. This is 20,000 feet. The next thing we need to focus on is the angle of elevation. We're elevating from a horizontal. Well, the ground is your horizontal, and we are elevating, it said, from the runway, which is part of the airport, to the airplane. So we need to connect the airport to the airplane. And what we've created by connecting these two is an angle of elevation. We're going up from the ground. So that 5-degree angle of elevation from the runway, which is part of the airport, to the plane, 5 degrees, goes right there. Then the only other thing that we have here is it's asking a question. How many feet measured along the ground is the airplane from the runway? So normally you would think airplane to runway, we're putting the X here. But it specifically said measured along the ground. So our X is going down there on the ground. So this is our thorough picture. It contains all of the information that we need. So now we've completed step 1. Now we need to do our labels like we did last lesson. So of course the first thing we always label is theta. That would be our angle, which is 5 degrees. We know across from 90 is H. Across from theta is always O, and the leftover side is always A. So if you look at the pieces that we have O labeled, we have A labeled, and of course we have theta. So if you think about our favorite word, SOHCAHTOA, which part of SOHCAHTOA are we using with O and A? Well, that would be the TOA part. So T stands for tangent. Tangent's attached to theta, which is 5. And then we are making a fraction O divided by A. So O is 20,000. And A is the letter X. So there's our equation. So now we have to solve it the same way we've learned. Well, we learned that when X is in the denominator, we start by getting X out of the denominator. That cancels those. So X times the tangent of 5 equals 20,000. However, X is not by itself. We need to get rid of the tangent of 5. The opposite of multiplication, we're going to divide by the tangent of 5. Those cancel. So now we're ready to type in our calculators. So if you pick up your calculator and you take 20,000 divided by tangent 5 and you hit enter, you should get 228,601 feet. And that's our final answer. So let's take a look at a second example. A support cable from a radio tower makes an angle of 56 degrees with the ground. If the cable is 250 feet long, how far above the ground does it meet the tower? So if you think about a radio tower, these are those long metal towers you see with the little red blinking lights. They're usually on the ground, but because they are so thin and skinny, they use big heavy cables to keep them stable. So if you think about what we're drawing here, first thing of course we're drawing is the ground. So here's the ground. We have a radio tower, something like a tower, something like that, on the ground. It has those little red blinking lights on it. And then we have a cable, and there's usually several of them, cables that attach to it and then go at an angle down to the ground. There might be one on both sides. That's a picture of what's going on here. So let's see what we know. We know that the cable makes an angle. So where's the cable at? Well, this is the cable right here. The cable makes an angle of 56 degrees with the ground. So cable, ground. So of course that means that 56 degrees is right there. It also says the cable is 250 feet long. So the cable itself is 250 feet. And we want to know how far above the ground does it meet the tower. So we want to know, where does the cable and the tower meet, which is right here, and we want to know how high that is. So that is our X. So now that we have an accurate picture, we're going to label our pieces. Our angle is always theta. Here's our 90-degree angle. So across from it is our hypotenuse. Across from theta is O, and the leftover side is always A. So what pieces do we have this time? We have O and H and theta. So if we think about SOHCAHTOA, O and H is that part right there. S stands for sine. Theta is 56. And we are setting up O divided by H. O is the letter X. And H is 250. So now we need to finish solving. We need X by itself. That means that this dividing by 250 needs to go away. The opposite of dividing is multiplying. Those cancel. So you are typing in your calculator 250 times sine of 56. And if you type that in the calculator and you round appropriately, you should get 207.3, and our units are feet. Okay, so those first two were pretty basic. The drawings are probably the hardest part, but now we're actually going to look at a more challenging word problem. So you are flying a kite with the handle, of course, in your hand, and your hands are 4 feet above the ground. You are using 300 feet of string to fly this kite. The angle the kite line makes with your hand is 29 degrees. How high is the kite flying? So there's several things here. You need the ground, you need you need the kite, and the string. So if you've never flown a kite before, you obviously stand on the ground. Don't make fun of my stick figures. When you're flying a kite, the kite does not fly directly above you. Wind pulls it diagonally. So somewhere over here, there's a kite flying. And you are connected to that kite with a string. So those are the things that are important in this picture. Now let's talk about some numbers. First of all, the kite that you're flying, the handle is in your hand. Okay, this is the handle. And it's 4 feet above the ground. So the first thing that we need to do is, from the handle to the ground is 4 feet. Then we also know that you are using 300 feet of string. Well, the string is what's connecting you to the kite. So this is 300 feet. Now here's the tricky part. The angle the kite line makes with your hand, not with the ground, with your hand, is 29 degrees. Problem is, you need to have a horizontal base. So from your hands, I'm going to go and make a horizontal line. That's the tricky part. This angle right here is the 29 degrees. The question is, how high is the kite flying? So we want to know, how high above the ground are we? So we're going to go straight down from there. So the triangle that you guys see is right here. We are trying to find out how high it is. So we want X to be right there. The tricky part, this 4 is going to be important later. Let's focus on the triangle first. Label your pieces. Theta is your angle. Across from 90 is H. Across from theta is O. Your leftover side is A. What pieces do we know? We know O and H and theta. So we just learned on the previous problem that if we have O and H, O and H is right there. S stands for sine. The angle is 29. Then we have O, which is X, divided by H, which is 300. And so there's our equation. Now we need to solve. Of course, we're going to start by multiplying by 300. And those cancel. So we have X equals. So pick up your calculators and type in 300 times the sine of 29 and hit enter, and you should get 145.4. The difference is I am not putting a box around this answer this time, and here is why. This distance is the part of the triangle. It's from here to here. This 4 is important because this 4 is also over here. So if you want to actually find the full distance the kite is above the ground, you need to add 4 feet to this answer for a total of 149.4 feet. So this was the tricky one because of that extra 4 in there. So far, hopefully none of these have been too difficult. Let's take a look at a couple more examples. A sand pile is 4 feet high. The diameter of its base is 10 feet. Find the angle of elevation of the pile of sand. So if you've ever seen one of those like hourglasses where the sand trickles down, when sand forms a pile, it's not straight up and down on one side. Sand piles tend to be flat on the bottom, and they have a peak in the middle like that. And they're usually pretty much the same on both sides. And that's the assumption we are making here. We are going to assume that this triangle is the same on both the left and the right. So here's the problem. The picture I just drew is not a right triangle. So to make a right triangle, we're going to take and drop a line straight down in the middle. So let's see what we know. A sand pile is 4 feet high. That's how tall it is. Well, that would be the distance from the ground to the top. So there's 4 feet. The diameter, which is the distance across its base, is 10 feet. So this right here from end to end is 10. But we only want half the triangle. So we need to cut this in half, and this right here is 5 feet. We want to find the angle of elevation. So here's my horizontal. I'm going up from there. So So that's the angle that I want. That's my theta. So let's take a look at some labels. Well, we already have theta labeled. Across from 90 is H. Across from theta is O. The leftover side is A. So if we think of SOHCAHTOA, we have O and A, and we're trying to find theta. So O and A is tangent. So tangent, now we don't know our angle this time. That's what we're trying to find. So tangent of theta equals O divided by A. O is 4, divided by A is 5. So we need to take the word tangent and move it over here. So if you remember from last lesson, if you want to move the word tangent, we can do that. But when it moves to the other side, it becomes tangent inverse. And it attaches to the 4 over 5. So picking up your calculator, to get the -1 here, we have to press second tangent, and then in the parentheses, 4 divided by 5. And you should get an answer of 38.7 degrees. So now we have a part B to this. Here's the thing. Now we want to know how tall will the pile be if the diameter is now 40. So in other words, this entire triangle is just enlarging. So we now have a bigger base and a higher pile. So here's what's nice though. This angle we just found is part of our new picture. So drop down, and you might 90-degree angle. So I'm going to write 38.7 in that angle. 38.7. I now know my base is 40. So this entire distance is 40, which means this is 20. And I want to know how tall. There's my x. So let's label our pieces. We have theta right here. Across from 90 is H. Across from theta is A. And, I'm sorry, across from theta is not A. Across from theta is O. And the leftover is A. So we know O, A, and theta. So again, O and A is still that same part. So we're keeping tangent, but now we know theta. Theta is 38.7. O, we don't know, that's our x. A is 20. And so now we are ready to solve. We are going to multiply by 20 on both sides. So x equals, pick up your calculators, 20 times the tangent of 38.7, and your calculator should tell you 16 feet. All right, so I'm going to have you go ahead and try this very last problem on your own. For those of you that don't know, if you read through the word problem, if you don't know what a giant sequoia is, it's just a really big tree. So see if you can draw a picture of what's going on and see if you can solve this problem, and then pick it up and we'll see how you did. Okay, so let's see how you did. You are standing at the end of the shadow of a giant sequoia, 150 feet from its base. The angle of elevation to the sun is 63 degrees. How tall is the tree? So the first thing, of course, we need is the ground, because you and the tree are both standing on the ground. So the tree is over here somewhere, so we're just going to draw a tree. Now, shadows, because that's what we're talking about here, is the shadow of the tree. Shadows are on the ground. So this tree has a mirror image on the ground that's its shadow. And of course, you are standing at the end of the shadow. So you're over here. So this is you at the end of the shadow. Now here's my question to you. They mentioned the sun. In order for the shadow to go this direction, where's the sun? Well, if you understand anything about shadows, the sun must be over here somewhere in the sky. That's the only way for the shadow to be on the ground this direction. So what do we know? We know that you are standing at the end of the shadow of a tree 150 feet from its base. So you are 150 feet from the base of the tree. So we're going to put a 150 down here. We also know that the angle of elevation to the sun, so we're going from you up to the sun, is 63 degrees. So 63 degrees. How tall is the tree? So we are putting our X over here representing how tall the tree is. So let's label our pieces. The angle is always theta. Across from 90 is H. Across from theta is O. And the leftover is A. So of course we have SOHCAHTOA, O, and A, and theta tells us that we are using tangent. So tangent, theta is 63 equals O over A. O is X, A is 150. So X over 150. You should have, if you did it correctly, multiplied by 150. You should have typed in your calculator 150 times the tangent of 63 and gotten 294.4 feet. And hopefully you got that question right. And that's the end of our lesson.